Welcome to today's lesson, Chapter 4.5, Quadratic Equation by Angelica Andrews and V. Tran. You're probably thinking, what in the world is a quadratic equation? But don't worry, in this lesson we'll show you everything you need to know about it. You could solve some quadratic equations in standard form by factoring the quadratic expression and using the zero product property. The zero product property states, for the product of two factors to be zero, at least one of the factors must be zero. Like this example here, AB equals 0, then that means that either A equals 0 or B equals 0 to make AB equals 0. Now let's try it. Don't worry, this first example will be easy as pie. We first factor x squared plus 6x plus 8 equals 0. We must find two numbers that multiply to make 8 and add to make 6. We find that 2 and 4 meet these requirements. So then we factor parentheses x plus 2 and parentheses x plus 4. Next, we use the zero product property, which means we set x plus 2 equals 0 and x plus 4 equals 0. We then subtract 2 to the other side and we get x equals negative 2, and we subtract 4 to the other side, which we get x equals negative 4, and those are your answers. There are also the two x points that your graph intersects at the x-axis. Now that you've got the basic down, let's solve with tables. Use the table feature on the graphing calculators to find the zeros. Enter the equation x squared minus 11x plus 24 in standard form as y subunit 1. Next, press graph and it will graph your equation. The point where your graph intersects the x-axis would be your 0. You can also view it as a table. As you can see, when our equation is set to 0, x equals 3 and 8 would satisfy our equation, and those will be the points that crosses at the x-axis. Now that you've got that down, let's try something a little more challenging. Solve 6x squared equals negative 19x minus 15 by graphing. Our first step would rewrite the equation in standard form. Make sure that in standard form, the degree of the equation is going from greatest to least. So, in standard form, it would be 6x squared plus 19x plus 15. Now, don't be in despair. We will learn it together, and it's much easier than it looks. Now that you found your equation in standard form, use the table option and plug in the equation 6x squared plus 19x plus 15. Use the zero option in calc feature to find the zeros. The solutions are negative 1.5 and negative 1.67 round to the nearest hundredth. These two solutions are the points where your graph intersects the x-axis.
Time to do an even harder problem, but don't sweat it, we got this. The function h equals negative t squared plus 1,700 gives an object's height, h, in feet at t seconds. What does the constant 1,700 tell you about the height of the object? When will the object be 1,000 feet above the ground? When will the object be 940 feet above the ground? What are a reasonable domain and range for the function? Let's begin with the first part. The function h is equal to negative 16t squared plus 1,700 gives an object's height, h, in feet at t seconds. So what does the constant 1,700 tell you about the height of the object? Well, 1,700 is your constant term, so it adds or subtracts to the variables. It will always remain the same, and it remains unchanging. The constant in this case shows that something is 1,700 feet above initially. Now considering that with the variables, In this case, the constant would mean that the object's height is already 1,700 feet, even when the seconds are at 0. As the time in seconds increases, 1,700 feet will always be added to the height the object loses over time, or negative 16t squared. So, the constant tells us that the height of the object begins 1,700 feet above the ground, when the height begins to change in relation to the time. The function h equals negative 16t squared plus 1,700 gives an object's height h in feet at t seconds. So now let's try the second part of that. When will the object be 1,000 feet above the ground? Don't worry, you got this. First, 1,000 feet is equal to your height. So substitute 1,000 for h in the function h equals negative 16 squared plus 1,700. So you should get 1,000 equals negative 16t squared plus 1,700. Now let's solve. Subtract 1,000 from both sides to get 0 equals negative 16t squared plus 700. Once you get that, input this equation into the graphing calculator as y1. The root you will use would be in the positive side, for time cannot be a negative number, so round to the nearest hundredth. So, the object will be at 1,000 feet above the ground in about 6.61 seconds. Now, let's try the third part. When will the object be 940 feet above the ground? Take a few minutes to try this by yourself. Just pause the video and repeat the steps. Rewind if you need to review. Okay, so let's begin. Replace h in the function with 940 because 940 feet is equal to your height. So it should be 940 is equal to negative 16t squared plus 1,700. Subtract 940 from both sides so that the equation is equal to 0. Or 0 equals negative 16t squared plus 760. Now input this equation into the graphing calculator as y1 once more. Because time cannot be negative, again, use the positive root and round to the nearest hundredth. So, the object will be at 940 feet above the ground in about 6.90 seconds. Now one more. The function h equals negative 16t squared plus 1,700 gives an object's height h in feet at t seconds. What are our reasonable domain and range for the function? First, graph the original function h equals negative 16t squared plus 1,700 and find the positive root and the maxima extrema value. By now, the polar bear should be you. If not, then go back at the video to review. And rate yourself at the end of this video and practice some more problems to see how well you are doing. This is what your graph should look like. Remember, use the positive roots because time cannot be negative. So, while the function h equals negative 16t squared plus 1,700 has a domain of all real numbers, time does not occur in negative values. So, a reasonable domain for the time it takes would be at 0 is less than or equal to t, and t is less than or equal to 11. A reasonable range is 0 is less than or equal to h, and h is less than or equal to 1,700. You did it! You accomplished it! Now go on and try some more problems. See you soon!